Hi everyone, welcome to our talk about streaming with structure. I'm Nick Townsend, and I'm here with my ex-colleague, Kate Stanley. I'm a software engineer at IBM UK. In the event-driven event streaming space, I've worked in two of our products, Event Streams, which was our on-premise Kafka offering, and Event Endpoint Management, which is the next level in event streaming, in a way to catalog and socialize those event sources. Outside of work, I'm a keen cook. I'm recently dabbling with things like curing, cheese making, fermenting things. I do quite enjoy experimental flavors to the point where I, last year, triggered an evacuation of the office by bringing in an apple and garlic cake that had more garlic than apple. So I'm a bit of a liability around the office at the moment. Over to you, Kate.
Yeah, Nick, the things he's cooked have been very good, but you have to watch out for what's in them. So, hi everyone, my name's Kate Stanley. Recently left IBM, started working as a software engineer at Red Hat. Around all things related to Kafka, I love talking about Kafka. Anyone has any more questions about Kafka, then let me know. I also really like speaking, so I think a lot of the presenters have said this, but this is my first in-person conference since way back at the beginning of 2020, so I'm just really excited to be here and see so many people in person, and also welcome, of course, to everyone who's joining us on the live stream as well. So let's get started. So we're going to have a coffee break, because who doesn't like a coffee break? So there are plenty of applications out there that are hoping to show you how great your life will be if you adopt Kafka ways of doing things. So let's look at this particular example. This is an app that I'm shamelessly still using that Clément Escoffier created. Thank you, Clément. And basically here we have some coffee lovers that are going to be making HTTP requests to their coffee shop, and then the coffee shop is going to tell the barista, please make some coffee. And if you go and have a look at the code and run the code of this application, you'll find it works fine, you can get your coffee order. But actually, if you then scale up and decide, actually we want lots of coffee lovers, they're all going to go to the coffee shop at the same time, then we get a little bit of bottlenecking in our coffee shop, app starting to look like it's maybe not the best architecture that we could choose for this scenario. And so a mechanism that we can use to improve this and perhaps prevent that bottling where our barista is having to send the order back to the coffee shop before the coffee shop gets more orders is to look at event-driven architecture. Hopefully this is very familiar to a lot of you that are here. So of course we have some microservices that are publishing events, going into our event-driven messaging backbone, and then we have consuming applications that may be also publishing events. And if you go to conferences like these, you'll hear lots of people saying, well, if you're going to go event-driven, obviously you should use Kafka, because Kafka's great. I personally think so. I'm hoping a lot of people are already familiar with Kafka. If you want more info on Kafka, then, as I said, both of us can answer any questions. But just a recap for those who aren't aware, it's a distributed streaming platform. It provides scalable consumption, stream history. It's very scalable, highly available, and it has immutable data. So the idea is you produce your events, and they're like that forevermore. People can reread them. So you take our application, you add in Kafka as your event backbone, and you can run both versions of this code through GitHub on the link up the top. And you'll find that my application is so much better. My coffee shop is being able to take orders, put them on the event backbone. The barista can go make the coffees, they can take a break, go do something else. We can have more baristas, and this is great. And one of the main things that people are always saying when adding in Kafka in this scenario is, this has helped me to decouple my applications. It's allowed me to have my coffee shop and barista to act independently. I can scale them independently. All of this decoupling is great. But if you just take an application like this and add Kafka, how much decoupling are you actually getting? And how do you make sure that your coffee shop and your barista continue to have a harmonious existence together?
Thanks, Kate. So Kafka, at a protocol level, is stored in bytes. Producers will produce messages. They go onto the Kafka topics in bytes. Consumers consume the messages by receiving the bytes from the Kafka broker. So the question is, how do you make sure that the producer and the consumer are able to understand one another? Shall I take the clicker?
Yeah.
So the way this works is producers need to serialize their messages into bytes, and consumers need to be able to deserialize their messages from bytes. And so you might think, how on earth do we get the producer and the consumer to agree on these things? Well, the first thing is that you configure your producer to say the type of serialization you're going to be using when sending messages to Kafka. It's a simple property to say, use this type of serialization class. But then you'll notice that the producer then has to configure itself with the actual messages that are being created, say, in the Java level. So on the slide here, we can see that we've set up an integer serializer, but our producer is actually configured to produce strings. So the moment the producer sends this message, Kafka will catch it and complain that you can't serialize a string to an integer. So it means that if we've agreed that we want to have the topic using integers, but the producer is configured to send the string messages, then we catch it at the producer level. But the problem is that when you get to the consumer is only working on that agreed contract. So the consumer may know that it wants to deserialize from strings. If it hasn't been told the producer is producing integers, then it will happily be able to consume the byte stream from Kafka and deserialize that into a string. What this would look like at the code level is that the consumer would appear to be, in this case, consuming what would be an empty message, because the producer has produced an integer of 1 onto the Kafka topic. The consumer has received that byte stream and deserialized it into a string. That string would be a non-printable character. So if you were printing out the logs by printing the record.value, you would believe your consumer wasn't functioning because the messages are being displayed as empty. But if you were to look at the length of that value, you would see that actually there is a value of 4. It has content to it that's not being presented in your application. And if you were to actually then convert the bytes represented by that string and parse it into an integer, you'd see that there was an integer of 1. Thus, there actually is value there. But if the producer was to send an integer 2, yet again, the value would be non-printable. Your consumer would still look like it was misbehaving, not receiving any messages. But when you convert the value back out, you would actually then still have an integer, a different integer at this point. So the question is, can we do something better to ensure that both the producers and the consumers are able to understand and speak the same structure, the same messages, and be able to understand one another? So if we switch back to the coffee shop example, we think, well, maybe we can agree between the coffee shop and the barista some form of structure. So we go for a simple agreement that the coffee shop will send messages in the format of a string, comma separated, where we go ID, product, customer, size. So the coffee shop could send a message onto the Kafka for the barista to receive, saying 1234, it's a hot chocolate, customer's name is Kate, and it's a size small. So the barista gets this message and is happily able to make those drinks because they have agreed between them on that structure. But what if the coffee shop decides to update the schema that it's to update the structure that it's using and adds in an additional field called marshmallows? So the new message being sent across is still a string, but in this case we have the additional parameter of true to indicate that Kate would like marshmallows on her hot chocolate. So when the barista receives this message, he can parse the string. Absolutely fine, no execution errors. But he starts to read this message, and it doesn't make sense. There's this true that has appeared out of nowhere, is not one of the parameters the barista was expecting. It might be he's able to just interpret and handle this, but it could be that he just has no idea what to do with this message and thus is stuck. Execution has ended. So the question then becomes, what can we do to include more information for the coffee shop and the barista to be able to agree on that format?
And that's where we come to looking at some sort of structured format. And a lot of people will say, okay, yes, a comma-separated string does seem like a bad example for how I would send my messages. I have to agree on the order. And I actually don't like coffee. I love hot chocolate. So I would be very upset if I didn't get my hot chocolate because of this. So let's have a look at what happens if we use some JSON. This gives us great structure. We have an order ID, we have the product, the customer name, and then the size. And the great thing about this is I can extend it, so I can just add an extra field that says marshmallows true. And we all know that there are plenty of libraries out there where we can say, actually, just ignore something that you don't understand. So if my barista hasn't been taught how to add marshmallows yet to the hot chocolate, then it can just ignore that field, and maybe the customer will be a little bit unhappy, but at least they still get their hot chocolate. But bringing in JSON doesn't actually give us enough. So it does give us some of this added structure, but at the moment we're using here a Boolean to say marshmallows true or false. What if we change this to say, actually, we're going to use a string of yes or no for marshmallows? There isn't any information in the JSON that tells us what types these different fields were supposed to be. You can see there's some strings, there's perhaps an integer for the order ID, or maybe that's a string. We don't seem to have any quotes around the small. Is that an enum? There isn't enough information here to actually get us all the way. And this is where a schema comes in. So a schema goes beyond just that comma-separated list of strings or that JSON. It's like a blueprint for your event. It's a fully structured, described way to say, this is the event that I'm actually going to be sending to you. So we would highly recommend that if you're going to be using Kafka, you should think about using a schema to represent your events. But what do we actually do with this schema once we've created it?
So again, we come to the question, how do we ensure that the producer and the consumer can both agree on a schema format? Where on earth do we want to store the schema? So one thing we could do is to configure both the producer and the consumer to use the same definition, the same file that is loaded at runtime to ensure they're sending the messages. And that's brilliant. Producer can read the schema, create a message, serialize it onto the Kafka topic. The consumer can read that message back off. It has the schema, so it can deserialize it back into something that it understands. But what happens if the producer decides to change the schema? Maybe there's some new fields that need adding. Maybe it finds an error in runtime and decides that actually there's a new version of the message. Or alternatively, maybe the producer decides it's multi-purpose and it's going to actually add more messages to that topic of different structures. The problem is the consumer still only has reference of that original schema. So it doesn't know that there's only updates. It doesn't know how to parse those messages. So perhaps what we could do is to put the schema into the message. So not only do we have the JSON structure of the message itself, but we have a schema field that explains the schema of that message. So when the producer sends the message onto Kafka, the consumer can deserialize, it can get the JSON, and it also has the schema that it needs to be able to create the object and handle the data. But the problem is, this means that that producer is sending that schema in every single message it puts onto the Kafka topic. And schemas don't tend to change. You want to have a source of truth in that schema that all the applications can use, and it's not likely to change. If you think of it like an API, the versions are more incremental as features are added. They're not something that changes day by day. So we are significantly increasing the size of our message onto those Kafka topic for every message that the producer sends, including metadata that changes very infrequently. So the question then becomes, if we don't store the schema in the message, where can we store it so that both producers and consumers are able to access the latest version of that schema? And that takes us to the concept of a schema registry.
Yeah, so what is a schema registry? It's basically just a centralized store for all of your schemas. You put it somewhere accessible to both your producers and consumers, and then as long as they can both talk to the schema registry, they can agree on the schema that they're supposed to be using. So hopefully so far we've illustrated why schemas are a good idea and why a schema registry is the right thing for you to do. When I talk to people about Kafka and schema registries, there's two questions that I think need answering. One of them is the question that people ask me all the time, but there's another question that I think people forget to think about. So we're going to cover both of them. The first question, which is the one we get asked all the time, is which format to use for my schema. There are plenty out there. We'll talk about some in a second. But that's kind of a big question that we get asked a lot. The second one is which schema to choose. What I mean here is, how does your application know which schema in your massive schema registry, and specifically which version of that schema, it should be using to serialize and deserialize the message? And that's the question that I think often people sort of forget to think about, specifically when they're looking at Kafka and Kafka applications. So we'll look at both of these. So let's look first at schema formats.
OK. So 3 typically used formats when writing schemas for Kafka is JSON schema, Google's protocol buffer, and Apache Avro. So JSON schema is human readable. It describes the structure of the message. It allows you to be able to generate code from that schema to be able to handle the messages in your classes. But JSON schema requires you to send the message in JSON, which has a size associated with it. All of your messages will be human readable, but they will be the size that is required to make them human readable. So perhaps you look at something which can serialize down to a smaller format, such as protobuf. Now, protobuf was developed by Google. The great thing with it is that from a proto file, which is the schema description, you can generate code in Java, in Python, in C, many different ways of being able to generate code for your application that can handle and deserialize the content in the Kafka topic, in the protobuf encoding, into an object. So we can see here that we've taken the proto object describing an order, and we've been able to generate a very easy Java builder that is enabling us to create an order in Java code. The downside, however, is that you have to then learn how to write a protobuf file. It's not as human readable, perhaps, as JSON schema is. So perhaps a middle ground is the Apache Avro. And Avro uses JSON in a way to describe itself. So the schema itself is human readable. But Avro allows you to encode the content as binary or as JSON. JSON allows it to become more usable when the message is sent onto the topic. But with binary, you can compress, and you get the advantages of compression and a smaller payload. Again, you can use code generation to generate classes from the Avro class. But in addition, the Avro library has the concept of a generic record. So if you wanted to get started very easily, you can actually just simply write a generic record handler that can take the schema and be able to pluck the fields out of it without needing to use any code generation libraries. And whilst we're talking about metadata and schemas, you also have another layer of metadata, which is the async API specification. And this is derived from OpenAPI, and what this allows you to do is to not only document the message structure, but you can document the actual application in itself. So not only have your producers and consumers been able to agree on a schema, they can also communicate via an async API document actually where the Kafka topic is, potentially the types of security that are needed to connect to it. And it decouples the application, the levels of communication needed by actually providing both a human-readable and machine-readable description of your producer, your consumer, and your Kafka applications. So let's say you've decided on the schema format that you'll be using. The next question becomes, how do your applications know which schema to choose? So they need to be able to know where to go to in a schema registry to get access to the schema that's there. Now, when you start writing a schema, you could look at creating multiple different types of schema. So identifying them, we've got ID1, we've got ID2, two separate schemas. You might, however, have an evolutionary schema. So you have a single ID that identifies the schema, but then you have version 1 and version 2 of that. Typically, when you're writing your schemas, version 2, you would like it to be backwards compatible, the ability to be able to parse messages of type version 1 and version 2 at the same time in an application, and to be able to handle when fields are missing, etc. But the idea being that in your schema registry, you want to be able to identify those versions, and you want your client to be able to understand which version it needs to be able to download. So a Kafka record is one mechanism which we could look at trying to inject some information that would detail where that schema exists for the particular message. And a Kafka record is composed of a key and a value, two sets of bytes that represent that total record. So maybe we can use these bytes as a way to add information about the schema. And so the one way of solving this is through the concept of magic bytes. So where you have your byte stream, you could actually separate the serialized bytes into a few chunks. You could add a magic byte. That is to indicate the presence of a schema. So when you're parsing through the message that comes out from Kafka, the magic byte indicates to say, yes, we have encoded the schema ID here. You'll need to parse this before you try to parse the actual message. You could then add in an ID that identifies that schema plus its version. And then you can add the serialized data. So what this means is that clients that are retrieving the data from Kafka can read through the bytes that have come through, and they can understand the presence of a schema ID. They can find the schema ID, and they can then look it up in the schema registry that the client is configured to use. And this can be applied to both keys and values in a Kafka record. So the key and the value can have their own individual serializers, their own individual schema. The alternative is we could look at adding things into the record header. Now, the headers were added in Kafka 0.11, which represents metadata that can be added to a particular record. So perhaps we could put the schema information into the header instead. So your client knows to look for a particular header in that record that contains the schema ID and the schema version. The things we have to consider when picking between a magic byte and a record header is that the magic byte is brilliant. The messages are straight in the event itself. They're in the message. They're there on the key and the value. But the alternative is that you could have the header as a way of encoding more information. So whilst the key and the value in the magic byte gives you the schema ID, with the record header, you could combine multiple sources of data into multiple headers to represent your ID and your version in that data. The downside of using the header is that it's not always accessible by some of the Kafka APIs at a lower level. We've found challenges in the past with Streams applications in being able to access that header at a low-level API level, whereas the magic bytes, because it's a byte stream, means it's available at any API level or any API provided by Kafka. But of course, the question then becomes, where we've got the schema registry, where we have decided on a format, how do we make sure that the applications themselves are all able to speak that same language, to understand where the data is coming from, to understand how the data is being represented, how the schema is being represented, and to be able to ensure that every part of the application is able to function using those same schemas.
Yes, and this is where SERDs and converters come in. And actually, this part of the presentation is partially why we came up with this talk. We found that actually we had a lot of customers who were doing a lot of different things with Kafka and struggling to get that seamless integration across everything. And that's because Kafka has a lot of different use cases and actually a few different types of application that you can run. So this is an example of a Kafka cluster with all sorts of different applications. If you've run Kafka for the first time, perhaps using the Quickstart on the website, then you will have seen a producer and a consumer. That's What we've talked about for the majority here, that's what people tend to start with. It's a basic produce, I send events into Kafka, or I consume, take them back off again. But there are two other projects that are part of the open source Kafka project, which are types of applications that are becoming more and more popular for people to use when they are using Kafka. So the first of those is Kafka Connect. So Kafka Connect is an add-on to Kafka, and it allows you to get data out of an external system and into Kafka, or from Kafka back out to another external system. And when you're running Kafka Connect, you run what's called a connector. So that's a specific process that is for a specific external system. So for example, if I have a database, I would have a connector for that specific database, and we call them source and sink connectors. But connectors in general are sort of configured in a similar way, so we'll see that in a minute. And then the final type of application that we often see running with Kafka is stream processors. So you may have all heard of Kafka Streams. Kafka Streams is a Java library. It allows you to really easily write applications that take data off a Kafka cluster, process it in some way, and then put it back onto the cluster. You can do all sorts of interesting things like join two different topics together, so two different streams of data together. You can look at windowing and looking at how a value changes over time. But this is an area that we see a lot of people developing applications in, but it's essentially just another Java application. Under the covers, it is producing and consuming to the Kafka cluster, but it's run using the Kafka Streams API. And just to make things less confusing when you're using schema registries, all of these types of applications are configured differently. I'm not sure what the background reason is of why they're all configured differently, but they are. So let's have a look at the different configuration that you need to know about depending on which application you're using to interact with your Kafka. So first we'll do producer and consumer. We did already sort of cover this one at the beginning. So we have a key serializer and a value serializer, and then the same key deserializer, value deserializer for the consumer. We find that often, actually, people don't tend to use schemas for their keys. Often it's just a string, an ID or something, so that's why Kafka allows you to choose separately both the serializer for your key and the serializer for your value. It could be that your key is a string and your value is a nice schema like Avro, so it's kind of up to you. But this is how you configure them. So you have your serializer and deserializer depending on whether it's a producer or a consumer. And of course, we said at the beginning that you get some defaults. The string, integer, I can't remember if there's a JSON one built in or if that's provided elsewhere, but that's not enough if you're using a schema. So what you're going to need is you're going to need a serializer that is specific to the schema registry that you have chosen, but also that is specific to the schema format that you've chosen. And the reason that you need both of these things is because the schema registry location, how that's configured to their application, will vary depending on the schema registry. There isn't one specific place in Kafka applications for you to provide that. So hopefully, the schema registry you have chosen will provide you a nice serializer you can use. And of course, Nick talked about the fact that we have this separation between the headers versus magic bytes. Because there's a difference, and you need your producers and consumers to agree, if one's using magic byte, the other one can't use headers, you need to have a serializer that's going to look in the right place. For some of the serializer, deserializer, well, I guess for some of the deserializers specifically, they sometimes will look, for example, for a magic byte, and then if they can't find it, look for a header, or vice versa. Some of them will only look for one or the other. It depends on the specific schema registry, how old it is potentially, because as Nick said, the headers were only added in 0.11, so that was reasonably early on, but schema registries were already a thing then. So you have to make sure you've got a serializer that's available for your schema registry and for the type of schema format that you want and for where you're storing it. And you'll see this is a theme that goes through the other types of application. So let's look at those. So for Kafka Connect, you provide what's called a converter. you provide the same configuration, whether it's a source connector or a sink connector. And again, there are some ones that are provided by default. So you can see we've got JSON converter, string converter, and a byte array converter. So these will all be fine if you're not using a actual schema registry, but if you are, again, you'll need to make sure that you can find the right one for your specific application using header versus magic byte, avro versus JSON or whatever, and then that's how you configure it. So far we've got serializer, deserializer, and converter. And then finally for Kafka Streams, we have a different setting again. So this one is called Serializers, which is obviously serializer, deserializer. And for the connect one, you'll notice there was only the configuration option for the converter value. So when you're doing connect, in general, a lot of the control of how the data is produced and consumed is given to the connector. So different connectors will do different things with keys. With streams, you have a little bit more control over how you do your SERDs. So you can provide the key and then the value. And again, there's some that are provided by default, byte array, string, and integer, but you'll need to find one that's very specific to your specific application. And one of the interesting ones about streams, actually, is you can provide this setting at a sort of global level so that all of the contact that your Kafka Streams app has with Kafka is using the same serializer or deserializer. But because Streams is pulling data from Kafka and then sometimes putting it back onto Kafka, when you're actually writing your Streams application, you can get quite specific about which parts you want to have serialized and deserialized in different ways. So it does mean, unfortunately, when you're writing these applications, the serialization and deserialization isn't something that you can just sort of say, someone else can deal with that. You do need to think about that. And that's something that we see a lot, is that people are using schema registries, or even without a schema registry, just running an application with Kafka, and they come and say, my messages make no sense, they're not in the format I was expecting at all. And it's normally because they haven't lined things up properly. So what does that mean when you're building a whole system with Kafka? So I've got an example here where we have an external system, perhaps a database maybe, and we're using a Kafka connector to pull data from that database, put it into Kafka. Then we're doing some processing on the data, putting it back into Kafka, and then, of course, consuming it, all using our lovely schema registry. Well, what this means is you have to be configuring your converter, your SERDs, and your deserializer, of course. But because you're using a schema registry, and actually you would have to do this regardless of you using a schema registry, you need to make sure that all of these agree. So it's not just about producing and consuming. If you're going to introduce things like Connect and Streams into your Kafka system, you need to make sure that your applications are agreeing all the way through. And of course, because Streams allows us to configure things a little bit differently for pulling from Kafka versus pushing, you could have, say, the converter and the serializer part of the SERDs agrees, and then the deserializer, and then the serializer and the deserializer agree. But you just need to make sure that across the board, you've got the same format, probably the same schema registry, and that you're making sure to have that header versus magic bytes. And if you don't get this set up correctly, then you will start to see error messages like, can't find magic byte, or can't deserialize this message because it has some sort of weird byte at the beginning, which is a magic byte. So make sure you're lining all of these up if you are going to be building a system with everything in. So we've talked a lot about schema registries and saying you should use one, and hopefully your schema registry provider will provide you the things you need. So what example schema registries are out there, and what should you be looking for when you're trying to pick one to work with your Kafka application? So we're going to talk about two. The first one we're going to talk about is Apicurio Registry. So this is an open source schema registry and works great with Kafka. It has plenty of format options, including the three that we've talked about today, which is Apache Avro, Google Protocol Buffers, and JSON Schema. It does also support async API, I believe, which we also talked about. And the Apicurio Schema Registry is actually designed not just to be used with Kafka, so it provides multiple different storage options. So you can actually store your schemas back in Kafka. That's one option that they provide, so it will store the schemas on topics in Kafka. Or if you're not using Kafka for storing your schemas, you can use a database like PostgreSQL if you want to. And then it has a bunch of different API support. And this is where you need to be thinking carefully about your choice of Schema Registry. So Apicurio support the Apicurio API, the IBM API, and the Confluent API. And what I mean by that is if you run your application with a serializer or a deserializer that was provided to you by Confluent, and they said it works with the Confluent Schema Registry, it will also work with Apicurio. It also means Apicurio provides you with serializers, deserializers, SERDES, and converters that work directly with themselves. And we have some, I say we, Nick has some from IBM that will also work with Apicurio. So when you're choosing your Schema Registry, that's what you want to be checking. Do they provide a serializer and deserializer if you're doing producer-consumer? If you're doing Connect, do they provide a converter? If you're using Streams, do they provide a SERDES? And do they then work with the Schema Registry that you want to use, and do they support the mechanism for finding your ID that you want? Apicurio support both headers and magic bytes. The second one that we hear a lot of people using is, of course, the Confluent Schema Registry, which I just mentioned. They have very similar format options, so Apache Avro, protocol buffers, and JSON schema. They only support the Confluent API. So what this means is if you write an application that's using the Confluent serializers, deserializers, you're good. But I don't think they support headers yet, but don't quote me on that, they may do. For a while, they were just supporting magic bytes. So it can have an impact on your choice of Schema Registry. So what have we talked about today? You should definitely be using schemas. Hopefully, we've labored that point enough. It does give you great structure. It means that if things evolve as your application develops, you can continue to evolve and you don't end up in a scenario where you have applications that can't read the data that is on your Kafka topic. And as we demonstrated with the integer and string, it's not something you can just ignore. You will hit problems if you're not thinking about the format types with Kafka. A Schema Registry provides a centralized store. It allows you to have everything in one place, accessible. Quite a few of the Schema Registries also provide options to help you evolve your schemas and to check, for example, is my schema backwards compatible? Is that going to make my life more difficult going forwards? So that's a really good feature that you wouldn't get if you weren't using a Schema Registry. And then choose your favorite format and identification mechanism, but just make sure you're using the same one across the board, because it can be easy. It can be easy, especially with things like Connect and Streams, to forget, oh, actually, I need to add a converter or a SERDES. We often find producer-consumer, it's kind of straightforward, but it's when you add those other types that people forget that they need to line everything up. So thank you very much for coming and listening today, and for those who've joined online. It's been great to be back in person. We've got a whole bunch of links here, so we've got a few different resources for you to get started with Kafka. So there's some stuff on developer.ibm, of course, the Kafka website. Strimzy is a Kubernetes operator for Kafka. And we've got a little starter app that's just great if you want to start Kafka and then test it out with some data. And, of course, the links to the Schema Registries. So with that, all I would say is I have got some stickers if anyone who is in the room wants to come up. And if you have any questions, I think we're submitting them via online so that then we can get them here in the room. But thank you very much. So I don't know if we've had any questions. I don't know what you want. So if people can submit online, that would be preferable. If people haven't logged online but would like to ask a question, then feel free and I'll just repeat the question before I answer it. Yes. You're going to have to speak up loud. She's got a mic. There we go.
Thank you. I'm not sure if I missed anything, but I'm worried about the amount of data that would be transferred if we transfer schema with headers. I would guess that you could, for example, just send the hash of the schema in the header so that the consumer and producer could verify that they are using the same schema without transferring all of it. Is this done? Or
so you're talking about, let me see if I understand the question. I think the question was, we talked earlier about putting the whole schema in the JSON body, and we then, of course, talked about putting the ID in the header. Your thought was, could you put the schema in the header and send that? Is that your question?
The idea of the schema is put in the header, yeah?
Yes, yes. So
Okay, cool.
The way it works is you need to identify what's the key information so that I can uniquely identify the schema. It might be a single ID, or it might be an ID combined with a version. And then if you're using magic bytes, you put your unique ID in the magic byte array, well, in your byte stream. And then if you're using the other mechanism headers, you just put the ID and perhaps the version in your headers.
Thank you.
I think as Kate was discussing, with regards to schema registries, each vendor will typically provide their own libraries for both serializing and deserializing, which means that as a developer perspective, you are just configuring those libraries. So you will say, here's where my schema registry is, here's credentials to speak to it, and here's the strategy that I want you to use for serializing with the schema ID in it. So that idea of using the magic bytes versus the header is abstracted away from you by those vendor libraries. And ultimately what happens at runtime is the SERDES libraries, so the serializers, the deserializers provided by the vendors, will read the message, understand, because of the configuration, how to get access to the particular schema. They will go and retrieve that from the schema registry, typically use local caching, etc., for performance purposes. But once they've got the schema, they can then do the deserialization into the object that you need. So the schema registry vendor libraries make this significantly more easier than trying to roll it by yourself.
Yeah. And the thing that we were seeing a lot was people were sort of picking up serializers and deserializers that they could find sort of wherever, and perhaps one of them they hadn't realized was configured to look for a magic byte, and one of them was configured to look for a header, and then they were getting odd error messages that they didn't understand. But if they had understood, oh, some vendors do it with the magic byte, some do it with the header, they would have easily been able to go, oh, this must be what the problem is, now I can fix the problem. And we just had quite a few customers who were saying, I'm getting these weird messages and I have no idea what to do. And we were like, we know exactly what's going on here, but it's because it's abstracted away that people don't realize quite what's happening under the covers. So we've got a question on the phone. I'll read it out. Since Kafka is already configuration heavy, what approach would you recommend for those who want to get up and running a little more quickly while still not getting too bogged down with a schema registry? So it is true that there's a lot of kind of configuration and things that goes into Kafka. I think from my experience, as soon as you're wanting to do something where your data is complex in some way, that's where you really do need to be considering a schema registry and a schema. If you're always just sending a message, which is one string, and say it's an ID or something, and therefore it's always just going to be a string, there's no additional information, perhaps that's okay. And I don't know, perhaps you could continue like that. But I think we found from experience that once you've kind of gone beyond that basic flow, you really do need a schema registry. And like you said, Nick, actually, the vendors make it fairly straightforward. If you get a schema registry like Apicurio, they provide all of the serializers and deserializers you need online. It is literally just a case of making sure the library is available in your application and just configuring a field, which you have to configure anyway. You have to provide a serializer and a deserializer. It's just a case of using one that somebody else gave you rather than the one that's built in.
Yeah, and I think a middle ground could potentially be using async API as a way to document. Because if you use an async API and document the application structure, then it means that you do have a source of truth for anyone who wants to write a new application or implement the particular business logic. Then they have a document that contains both where the Kafka is plus the schema, and you could use code generation to go and generate an application that uses this. It's a middle ground because obviously you've then put the schema into the async API document. If you need to change that schema, every application needs to be reconfigured, but it would be a potential middle ground as a way to say, actually, I've added some structure and documentation to my system without introducing the addition of a schema registry.
Yeah, I think that's a really good point, and also specifically for scenarios where you're perhaps providing a topic and you've got multiple people who are wanting to consume it, and you think maybe it's not going to evolve too much over time, but people are wanting to kind of get access to it, then that is kind of a really good use case. We had a question up there. I don't know if the mic got delivered to you. Yeah, go ahead.
So perhaps the answer to this is that sometimes the schema is encoded in generated classes, depending on which serialization mechanism you choose. For example, the protocol buffers, when you generate Java classes, you actually do not need schema to deserialize messages into such objects, because the schema is encoded in the deserialization logic of the class you are using. You just have to make sure that you want to deserialize the correct class from the correct topic. So this validation may be performed perhaps just by putting the class name, the fully qualified class name, into some header, and verifying that you actually are getting this in the message. So you have the benefit of using schema, but not in the schema registry. Avro, on the other hand, needs schema for deserialization because it needs both versions of the schema. The one you used when serializing and the one you are using when deserializing the message, so it can make these decisions of fields that you are adding in new version and so on. So perhaps the answer for this is to use protocol buffers without schema registry.
So I'm not sure if that's quite a question, but more of a statement. But I think it's an interesting kind of setup to how do you make sure your application has access to the schema, in terms of if you're going to generate the code up front, as you said, you've got that schema information encoded in your Java classes. The interesting piece comes what happens when your schema evolves. Mm-hmm. And what we've found is that actually, so it could be that you are using your schema registry at runtime in order to have your applications more easily adapt. Specifically with things like Avro, where you have the generic options, it allows you to more easily kind of have your application be able to understand different versions of your schema, and therefore you don't have to put up a new version of your application. Often what we do find is the way people are using it is, like you say, they're building an application where the schema has been used to generate some Java classes to understand their application. And then when it comes across, what they're doing is they're looking at that ID to understand, do I understand this specific ID? And then having to make some sort of decision. At some point, you need a mechanism to be able to say, this is the schema you should use. So it might be that actually your schema registry isn't necessarily being accessed at runtime, but you're using a schema registry so that through the build process, for example, you can say, oh, okay, there's a new version of this schema. My applications now need to be updated. I need to build new versions, push them up. I think either way, it's useful to have that one place where you know there's a single source of truth, because otherwise you're just relying on your developers to say, I've changed my schema, everyone, you need to rebuild your applications. And I think that can work, but a lot of the time the teams don't really talk to each other. So I think having that one document that has that one place it lives is really, really beneficial to mean you have a better flow, whether that's because it's being accessed at runtime or because it's allowing people to evolve their applications as soon as that new schema is available.
And to your point about protobuf, you're right. I can see the advantage of being able to do this without needing necessarily the full schema. The other thing I think that needs to be considered is that you have to, if you're picking protobuf or whichever serialization method, is that you also have to think about the clients and the language that your clients are written in. So JavaScript, for example, has limited Avro support. If there isn't support for protobuf, then you've just lost half of your client support, for example. And one final thing just to add is that one thing where we talk about versioning of schema that schema registries do provide is that some of the vendor libraries can have automatic warnings to clients. So you could end up with log messages saying you're using a version 1 of the schema to produce this message. It's actually going to be deprecated in a week. You need to then swap over. So you're right, there are balances as to which benefits and disadvantages and advantages you need. So we're not saying schema registries all the time, but there are significant advantages depending on the business use case to use a registry.
I think that's all we have time for. We will be hanging around a little bit afterwards, though, so feel free to kind of come up and ask questions, but we will leave it there so the next presenters can prepare. Thank you.